Hello viewers, in this lecture I will answer to a question that has been asked by a viewer. So this viewer wants to plot the graph of a system of fractional order differential equations that are defined with the Caputo operator. As you can see on the screen that he has two differential equations. While in the first differential equation, the fractional order used by him is alpha, and in the second equation, the fractional order is beta. In one of my previous lectures, I have explained that how can we solve a system of fractional differential equations defined with the Caputo operator with fractional order alpha, but I was using same alpha for each equation. So he has raised a very important and nice question for which I really appreciate him, that both the equations have two different values for the fractional order. So now he has given these two equations, two initial conditions, and now if alpha and beta both are equal to 1, of course, the system reduces to the classical system of ODEs. For other values of alpha and beta, we will have a fractional order system. So he wants to simulate for alpha is equal to 0.95 and for beta is equal to 0.90. Can we design a MATLAB code to plot this system along with these available conditions? So the answer is yes, we can design a MATLAB code for such a system as well. But before watching this video, I would recommend that you must watch one of my previous lectures wherein I have discussed the fractional order systems and their simulations with the Caputo operator. I will provide the link to that lecture in the description box. So let's go to the MATLAB code. You can see that on line number 8, we have the value for the step size h, 0.01. You can decrease it further as well. Initial value of the independent variable t is 0. Value for the first dependent variable x is 1, and for the second dependent variable y it is 3, as given to me by that viewer. The final mesh point I have arbitrarily chosen, that is 10. T shows integration interval, and capital N stands for the number of iterations. Now here we have the interesting line. Two different fractional orders I have mentioned, alpha 0.95, beta 0.90. Line number 13 and 14 is what we have. The fractional order system of ODE is also called predator-prey system. So now with these conditions and available data, how we can design a code for the simulation of this predator-prey system under these conditions. So a simple for loop is required wherein I have used the fractional forward Euler method. So let me show you the for loop, and if you recall from one of my previous lectures on fractional forward Euler's method, this is the same loop I had used over there. Now the only thing and the most interesting point, the answer to the question is, for the first equation, since the viewer said the first equation is a fractional order differential equation with order alpha, you can see that on line number 20 in the numerical scheme I have used the fractional order alpha. While the second governing equation in the system was a fractional differential equation with fractional order beta. So you can now see line number 21. Here we have the same numerical scheme, but this time alpha is replaced by beta. That's it. This is the only change we have to bring to simulate a system with different fractional orders. Now let's suppose if you have a third governing equation with the fractional order gamma, then what you have to do, you have to simply copy this line number 21, say, and then wherever beta is written, you will mention gamma. So in this way, you are going to actually simulate a fractional order system wherein each governing equation has its own fractional order. Now let's plot some results. So in figure 1, I'm interested in plotting time series graph x versus t. In figure 2, let's plot the y versus t. And then in figure 3, I'm going to plot a phase plane, let's say y versus x. So run the code, and then here we have all the three required pictures. As you can see on the screen, this is figure 1 for x versus t, figure 2 y versus t, and this phase plane y versus x. So I hope it helps. Now you have seen that how we can simulate a fractional order system with Caputo operator while the system has different fractional orders for each equation. And this code is using well-known numerical scheme called fractional forward Euler's method. So I hope it helps you. Finally, I would request you to like, share, and to subscribe my channel. Thank you so much for watching the lecture.